Okay, just had to press the button the right way. Okay, hello everybody. Thanks for coming. We have with us today Tim McCobb of the USGS. He is a groundwater hydrologist with over 20 years of experience. His presentation today will discuss the project he's doing for our island on the effects of sea level rise and climate change on the groundwater of the island, which is really important. He's going to highlight the progress on the data collection that's been done so far, the data compilation that they're doing, the model construction, and the remaining data needs and how we might be able to help him. Okay, Tim, thank you very much for joining us.
Thank you for having me. It's long been on my list of things to do and people to update. Are you seeing my full screen of the presentation?
Yep, there it comes.
Yes, now I am.
All right, great. Just give me 1 second to get situated over here. We use Teams, so I'm not really, yeah, there we go. Okay, yeah, well, thanks for having me today, and I'd like to give an update on an ongoing project. This work is being done in cooperation with the Mass DEP. It's funded 75% by them and 25% by the USGS cooperative funds. So I'd like to give an update on this ongoing study. It's a groundwater modeling study, and talk about the study objectives, the approach, and then discuss some data compilation, like Sherry said, and some remaining calls for information and data that may be helpful. So a little bit of background slides here. As you know, the unconfined coastal aquifers are vulnerable to the effects of sea level rise, or potentially vulnerable in climate change. These effects can include surface inundation, changes to the position of the water table, the freshwater saltwater interface, or changes to stream base flow. These increased groundwater and sea levels could result in problems with infrastructure. It could be basement flooding or septic system flooding. Saltwater intrusion to public and domestic wells could also be a problem, and disruption to sensitive coastal wetlands. Sea level rise projections through 2100 for Woods Hole over here on the right show that depending on the scenario that you're looking at here for these projections, sea level rise could be greater than 2 feet, is up as high to 6 feet with some of these higher level scenarios. Predicted temperature here, this on the bottom left here, so this is downscaled global change models for Dukes County. This is an ensemble of, I think, 22 models. You can see for these two scenarios, this is SSP 245. That's what I call the moderate stabilization scenario. And SSP 585, that's what I call business as usual. You can see that in either of those cases, we have a pretty steady increase, a little bit moderated here in the blue line for temperature over time through 2100. So there's definitely an increase in temperature, and that's going to affect evapotranspiration and recharge. On the right side there, precipitation is not, the trend there is not as clear. It does look to get a little more variable with time in the distance, and there's possibility that we could see shift in patterns of when it occurs, when the precipitation occurs, more recharge during the winter months and less during the late fall. So these all go together here and can affect our recharge rates or recharge looking forward with these projected models. So our study objective here is really to develop a transient groundwater flow model using the latest methods that we have at the USGS to develop a transient groundwater flow model for the whole island, to improve the understanding of the island flow system, evaluate the effects of sea level rise and changing recharge on the fresh groundwater system, with the focus here mainly on the primary and secondary aquifers here from this Delaney figure here back in 1980. We're really focused our study on the top 170 feet or so of the aquifer, but we are including going all the way down into bedrock and including the western moraines in our studies as well. And then the last objective there is to evaluate water management scenarios, and this is where I need help from groups like this, is to develop with stakeholders we're talking about 3 to 5 water management scenarios, which I'll talk about in a minute. Just a little bit of background, and this is probably a review for most of you that you know this as well as I do. A little bit of background on the hydrogeologic framework and on the geology side. Martha's Vineyard, as we know, was formed about 23,000 years ago, plus or minus 1,000 years during the retreat of the last ice age. It's characterized by this broad, flat outwash plain, the orange here in the superficial geology map. This consists of coarse-grained glacial deposits, and this is where our primarily where our water supplies come from. On the east, below this outwash here, is the thin terminal moraines here on the eastern side, and then to the west here we have these thrust and end moraines, which are a much more complicated system, and we'll talk about a little bit. Thrust and end moraines that form this northwest spine of the island. The deep hole here on the right was drilled in the late 70s as part of the study by Delaney. Just here east of the airport, and it shows you have these glacial deposits sitting on top of these thick upper Cretaceous coastal plain deposits, which tend to be fine-grained sediments, very thick in the system, down to about 820 feet, where they almost encounter bedrock there. On the right here, it also shows the salinity profile, and for the most part, salinity was fresh down to about 500 feet below land here, where it started to slightly increase to about 2 parts per thousand at about 800 feet below. So we have this freshwater lens sitting on top of this saltwater system at depth. On the hydrology side, we have unconfined water table conditions here. The water table rises up to about 20 to 25 feet as you move towards the west. In the western moraines, it's much more complicated and complex here by this conceptual figure here. We have confined and unconfined conditions. We also have perched and artesian conditions. And so we have these tills overlaying these layers of sands and clays and fine-grained materials, and it's quite complex back out there. Slightly less than 50% of the precipitation recharges the aquifer, and that mostly occurs during the winter months. And then I also have plotted here these observations that are measured monthly by Sherry and the Martha's Vineyard Commission. These are critical measurements at 9 wells in one continuous well that's reporting 15-minute data here at the site of that deep hole. So the approach to our project here is using ModFlow 6, which is the latest generation USGS flow model that has flow and transport capabilities. For this system here, the transport is of the saltwater density in the system, and that will be used to simulate the freshwater saltwater interface. It's a transient model, meaning it has a time element to it. We're going back in time to 2000 on a monthly time step or a monthly time break. And then looking forward, we're going to 2100 using those downscaled climate change models. So our goal here is to build in past and predicted recharge periods. Like I said, we're going to use those 2 selected global change, SSP 245 and SSP 585, to look at how recharge changes over time going forward to 2100. Sea level positions will also be built in from 1 to 6 feet. This will be a stair-step approach where we determine from LiDAR or elevation data sets where the position is, or how do we delineate that position, what that elevation actually is, and then we time that for these 2 different emissions scenarios looking forward. So why do we care? What are the planned analyses, and what are the outcomes that we hope to get out of this? How is this beneficial? When we're going to evaluate sea level rise using this model in climate change on the general hydrologic budget of the system, how does the balance change at these different conditions? What does the water table shape and position look like? How does that change over time? You really need a three-dimensional groundwater flow model to understand the shape of these lenses and how it may change as levels come up. Estimates of high water levels, that is like depth to water maps, how those are changing with these scenarios. Groundwater inundation mapping, where the water table may rise above land surface, and that would likely be nearest the coast, of course. The position of the freshwater saltwater interface, especially near domestic and in public supply wells. We're also going to look at groundwater exchange and selected embayments and how that may change the groundwater delineation or the groundwater contributing area to individual embayments and how that may change in these different conditions. Changes in stream base flows for the few streams that are out in the west there, and then go through these water management scenarios that I mentioned before, developed with the stakeholders' input here. So getting into a little bit to the nuts and bolts here of model development and what our model looks like, where we stand, and some of the data that's gone into it. And then this is a ModFlow 6 model. The active extent of the model extends about a half a mile, or exactly a half a mile offshore. It has a 100 by 100 foot resolution. And I've got a little inset there to kind of illustrate what 100 foot by 100 foot looks like. Here along the coastline, this is a pretty fine model, even for a regional model. This is quite fine given our computing capacity nowadays. But there still is a bit of upscaling when you're talking about delineating a shoreline and putting it into a model. It's 100 by 100 foot resolution. There's 16 layers total as built now. Like I said, most of the focus of the model is in this shallow, or the upper 12 layers or so, where the thickness is about 5 feet, 5 to 7 feet per layer. And then as we get deeper in the system, these layers get thicker in the coastal plain sediments. So we're really focused on that upper shallow portion. As I said, it's transient. We're going to have monthly time steps looking back to 2000, and then future we're going to do a combination of seasonal time steps and monthly time steps. So just a little status, we've now built out the framework for the model. We have it running. We're now verifying the boundary delineations, building out our stress periods and all the data that goes into those, as well as our observation data sets. And the observation data sets are what we are calibrating the model to. So we've really been in the data compilation phase, and I can talk specifically about a few of these on the next slides. Our boundary and information that we've been collecting is the coastline positions. We're using both the NOAA's 2017 projected coastline positions, as well as LIDAR. We're looking for coastal, we've been collecting coastal pond bathymetries for wherever we can find data on that. We're compiling groundwater levels, stream flows, positions of any indications of the position of the freshwater saltwater interface. Coastal pond salinities are important to our model. On the stresses side of things, we've been compiling all the pumping records back to 2000 by well on a monthly time frame. And we're also looking at return flow. How does the wastewater return into the system? The recharge on this project here is a really critical part of the project. How, the recharge is what drives the system, and recharge is where we're building in that climate change. We're doing that using what's called a soil water balance model, or an SWB model. That's a separate outside model that then gives us our input for these recharge data sets, and I'll talk about that in a moment. Geologic framework is important. We've been spending a lot of time looking at borehole lithology, and that kind of leads on to what our hydraulic conductivity field will look like, or that structure, that geologic framework that we're building into the model. And we're also looking at bedrock surface, and we collected some data related to that I will review as well. So I mentioned the soil water balance model, and this is really, it's an outside model that ultimately what it produces is a spatially variable recharge, groundwater recharge pattern. So over here on the right, I show mean annual recharge. This is for the 20-year period, 2000 to 2020. And you can see that there's quite a bit of variability in that pattern of recharge. And that's based on landscape characteristics mainly, but also climate and where rain falls, et cetera. So the way this SWB model works is it takes landscape characteristics, such as land cover, soil groups, available water capacity, and slope of the land, puts that along with these climate data sets. So when we're looking back, we're using what's called DayMet data to look at daily data that we know for the last 20 years or 23 years. And then looking forward, you're using these projected models for our climate, so our temperature and precipitation that come from those projected models. And then there's some model parameters like root zone depth that go into this soil water balance model to produce these arrays of groundwater recharge. So at this point, we have 1,200 time steps, monthly recharge from 2000 all the way to 2100. That's spatially variable. And what you can see here is it does vary greatly. If you're in the moraines, forested moraines here, you have pretty low annual recharge, whereas if you move over to a gravel pit out in the outwash plain, you could have some pretty high annual recharge rates. And so it does vary quite a bit, and it does matter. Another part of data compilation, or important part of this model, is the topobathymetry. I've been doing is pulling together these 3 different data sets to get to this merged topobathymetry, and I'll talk about that in a sec. But what these 3 data sets are is offshore bathymetry from NOAA 2017, the LIDAR elevation, that was collected for Sheriff's Meadow Foundation. This was in March and April 2021. This is a super detailed data set. It has 20 points per square meter. It's super valuable to this project, and I'm appreciative of them sharing. And then the final here is pond bathymetry. That I've been collecting as much pond bathymetry information as we can. This comes from multiple sources, whether it be MVC files or MEP reports, consultant reports, and they come in all sorts of forms as well. There's points and there's contours, and they come in a variety of datums, whether it's depths or elevations. And so what we've been doing is for 30 of those ponds, we have known data, and for 18 of those, we've estimated what we think the bathymetry might look like. And so we take these 3 data sources and we put them all into a merged topobathymetry, what you see here on the right, in one single datum. This is feet in NABD 88 at 1 meter resolution. And so you get this very detailed top surface, and this becomes the top of our model. And so I've put the model grid in there just to kind of give you an idea of the downscaling that does take place. We do need to map it to that model grid, but there's quite a bit of information and detail in here as far as elevation. And why this is important is as sea level rise comes up, this is kind of going to be the static top of the model. We know this is a pretty dynamic place here, but we're really locking these landforms down. And so this is the basis for the 1 foot through 6 foot rise as we look through our projections. Another element here has been borehole lithology and coding those, and we've uncovered over 1,600 boreholes on Martha's Vineyard from USGS site files going back to the 1930s, and then the most recent has been through the Massachusetts Drillers Database for all the domestic wells, monitoring wells, and other wells that have been drilled out there. So we've been going one by one through all of these points and classifying those into 9 categories. We're also confirming, and the state has been confirming their database to make sure that the XYZ location is correct. Here's an example from Tisbury of a classified borehole. I think this is up in this area north of Seth's Pond. And so this is pretty typical. You see some coarser grain at the top, and then you go into these thicker clay zones. This is a very thick clay zone, about 70 feet thick, and then you get down into the sanding gravels below that, and this is typically where the domestic wells are screened. But what we're doing is we take all of these 1,600 boreholes and we put them into this framework here, and so we can start to look at them in space. And so here's kind of an oblique view looking north, and I know it's hard to see, but you can see that deep hole there in the middle where the darker blues are clays and fine materials, and these orange and reds are coarser materials. And so you can see that the coastal plains are pretty fine down deep, coastal plain sediments. And you see these oranges and reds are these outwash plain sediments in general here on the eastern half. As you move up into the western moraines, you see lots more occurrence of blues, fine grained sediments, silts, and clays. We've looked in depth here about trying to uncover patterns in these, and it's really difficult. They're so variable just by moving a few hundred feet. It's quite variable. We've also been looking at the position of the where water is detected in each of those boreholes, whether it's above, below, or deeper in the system relative to where it's screened, to try to get a handle on where the water table is. So we take all of those boreholes in that 3D framework, and what we do is then do an interpolation here, where we assign values for each of those classifications. This is based on literature here, and it's just a guideline or guidance. We then put that into this, and here's an example of about sea level from 10 to 0 feet above NAVD 88. We have this interpolated surface here where you can clearly see the outwash plain here, and then the moraines, the finer grained sediments there. But these are a series of 10-foot flat intervals. There's a total of 65 layers. If you look here on the right, this is a section running north to south through here. You can see, you get a pretty good view here of what it looks like in this textural model space of the moraines, and then moving into the outwash plain, and how that all stacks up and connects together. So this really becomes the starting point for our model, or our geologic framework here. So these values aren't absolute. As we go through the calibration period, these values will change to match our observation data sets. But it's a great starting point where we're actually using and honoring all those data points that have been collected and logs that have been submitted. There's a couple of next slides here are actual data that we've collected from a geophysical survey, or 2 surveys in May and in October of last year. The first one is depth to bedrock. This was using what's called a passive seismic HVSR device. It's a passive seismic box. It's a tiny little box here, that blue one there, that's placed on the ground and coupled with the earth. And what it does is it uses the wind in the trees and the passive noises of the above ground to use that as a signal for the seismic device to determine elevation or depth to bedrock. So before we went out here, there's pretty limited information on the depth to bedrock below Martha's Vineyard. Here's the bedrock surface, kind of conceptually from Oldale's work in the geologic story, showing bedrock depth from 600 to about 1,000 feet below land surface, or it's unclear what the datum is here. What we did is we went out to a total of 23 locations where we placed this box. It takes about a half an hour to let it equilibrate and make its measurements. And so what you see here is we have a pretty good understanding now of what the shape of the bedrock surface looks like. These are elevations of bedrock surface. And so we're at about minus 600 feet along this northern shore to minus 700 as you move here. And then the south shore varies quite a bit from between 800 and at about 1,000 feet, minus 800 and about 1,000 feet. So it makes sense. You have this south, northwest to southeast sloping bedrock surface, very similar to what Olddale saw there, but we have a little more undulation built in now when we start to make specific measurements. And so this becomes the bottom, the absolute bottom of our model. We also have been, and more importantly, we've been looking at the freshwater saltwater interface using geophysical methods. And so here at 15 locations, we did using what's called TDEM. It's a time domain electromagnetics survey. At 15 locations, we were able to determine the depth to this conductive layer, which is the saltwater freshwater interface. And what this tells us is how fresh or how thick the freshwater aquifer is at each of these locations. And so it's what you can see where these arrows are is it varies quite a bit from site to site. It depends on the material that it's in. Here's a site that's on the border of the moraines at Chilmark Pond Preserve. That's about 463 feet below land surface. But as you move, as you move eastward here, these sites all along the coast tend to be in this range of 50 to 80 feet below land. So you have about, and then you have to account for the unsaturated zone. So we're talking somewhere between 40 and 60 feet of fresh water at these locations here. As you move on the north coast and through the moraines, you see that they're much deeper, this interface break. James Pond up here is at 266. The eastern coast here is 150 to 200 feet, depending on distance from shore and then what the materials are that you're in. So these are critical calibration targets or calibration points that go into our model, gives you that shape of that interface, which is such an important part of the study. I wrote here at the bottom data call. I am reaching out to ask for evidence of high salinity groundwater, whether it be from monitoring wells or domestic wells. If anyone has heard of any or anecdotal evidence of any kind of indication of that, I'd love to hear about it. So please reach out. My contact information is at the end here. Another data compilation, or a really important one here, is groundwater levels, and this is the basis for pretty much all of the calibration for the model. I wanted to highlight the 9 wells that are measured by the MVC and reported to the USGS. They're measured monthly by Sherry, I believe. But I also wanted to point out this website here, and this is what we call the web Groundwater Watch or web app to look at. This was developed locally, and what you can look at is all of these water levels across New England, but particularly if you want to zoom in, it's interactive and you can click on a point and it will tell you what's that record, what's the record length for that site, where does the water level fall currently in history or looking back in time. And so you can produce these pretty useful maps here, or plots here. Here is the, shows you the monthly means for each month going back 2 years, or for the full period of record, but it shows you back about a year. And what you can see at Edgartown 52 and all the sites on both of the islands over the last part of 2023, water levels got very low, as you're probably aware. And in fact, in December and in January, they were near record low for January within about 0.4 feet. Thankfully, things are starting to come up with recharge. The recharge period here, we're coming back into the normal range for this time of year for March. But it's a pretty handy tool, and it's been interesting to watch how the islands have been much drier, not getting these big storms that the mainland has been getting over the last, not just last year, but the last couple of years. So and that has led to these lower water levels. So it's a pretty handy tool. I would suggest you copy that and check it out. But again, on our data compilation for this project, we've been trying to locate and pull out as many groundwater levels and stream flows as we can locate. So we've been digging through all of our USGS files in all of the consultant reports that we can find. What we're doing is classifying those really based on a weighting system where these network wells that the MVC is measuring monthly get the highest weight. We know their elevation, they're well surveyed, they're well maintained, and we have a great record and period of record. And then we can go through these, but USGS has a whole series of wells and measurements that have been made to a known datum. We have some that are a lot that have been made to poor datums or unknown datums. And then we also have here, and I've included here, the Mass Drillers database. They do report a depth to water. That is a depth from land surface or from some unknown datum, but it is worth noting and including as prior information in this for sure. Stream flow sites, we've been looking at flows here. These are from the Millbrook watershed folks, and also the MEP reports. We're kind of trying to get a handle on all that have been collected out there. So here's my next data call or request for information. We're really looking for more recent discrete groundwater levels and monitoring wells that could possibly be measured or that are regularly measured. I've reached out to boards of health and the water departments, and I'm aware of a lot of studies done in the past by many different groups, but we're still at that point now. We're trying to compile a good list. Our hope is that we can get out there in May and do a water level snapshot where we go and measure all of these wells that we can find all in a 1 or 2 or 3 day period, to get a view of what that snapshot of what the lens looks like. Our plan is to bring out our surveying crew to measure the MP to a known datum. We're also looking for information on pond levels and opening dates, and Great Pond Foundation has been super helpful in providing information on that. And we're also looking for evidence of groundwater inundation, maybe near the coast where someone is suddenly has a flooded basement. We'd like to hear about that, or for more information. Another part of our data compilation has been stresses to the system, and this would include, public water supply pumping. As I mentioned, we have monthly by well is now compiled through 2022. We're hoping to get our hands on the 2023 data soon. We still need to decide how we're going to simulate future pumping, whether we make that an average of the last few years or we have a growth factor into that. But we need to decide and base that on something solid here. So that's one of the remaining questions we have to determine. Wastewater flow is also accounted for in the groundwater flow model, either as return flow to wastewater treatment facilities or as parcel scale return flow in areas of septic systems. So we hope to do that based on water use, where you have a consumptive loss and then a portion goes back into the system as recharge. And then finally, as I've mentioned a couple times here, we're looking for stakeholder input in 3 to 5 test cases for scenario testing. I've put a couple examples there of either looking at a drought condition or future pumping demands, additional water sources, change in return flow, whether you increase in sewered area or decrease in sewered areas. Those are all possible as part of this scenario testing. And so we're hoping to get agreement on what might be some good test cases that we can use our model for that's productive. The products for the study will be a USGS scientific investigations report, and this will document the data compilation, the model construction, and the findings. We'll also have a model archive, and so what that will be is a publicly available version of the model, all the calibration information and simulations, and it's now web-based, so anyone can go and use that. It'll be available for consultants and water departments, and anyone that would want to try to run a mod flow model for anything. And it is available to look at things like contaminant transport or nutrient loading, groundwater delineating groundwater watersheds. So it is a publicly available tool that would be available. Data release in NWIS, any new information that we're collecting will go into our NWIS database, including water levels, the borehole coding, the bedrock information. We maintain a project webpage, and then we have an outreach component to the project. So the hope or expectation is as this report and model archive will be complete at the end of 2025. So we have a little ways to go, but we need to get moving. So I'll stop there with questions if anyone has any.
I see Ben Robinson's hand up first.
Yeah, thanks, Richard. Thanks, Tim. Great presentation. Really interesting work. And for the NBC staff on the call, we're also doing a carrying capacity study with the Army Corps, and we're looking at drinking water and groundwater and other issues. And that would be certainly something that you should be aware of. A lot of the data sets that you have are stuff that they're actually looking for. And so we should put you guys in contact with each other so that that their model they're building for carrying capacity can relate to the models that you're building, the same data. So great presentation. Thank you very much.
Okay. Yeah, feel free to reach out via email there. I'm happy to share.
Was amazing. Okay, anybody else? I'm not seeing anybody else's hand up. If you've got a question, just speak up.
Yeah, here I am wanting to ask something. Do you hear me?
Yes.
Do you
Oh, it's
hear
on
me?
it. Yes, go ahead. Go ahead. Yes, I hear you.
Yeah,
Yep.
thank you. Yeah, so I'm wondering here, as you're talking about the water, what do you think about the wastewater treatment facility in Tisbury that has its leaching field within the zone 2 of the well that pumps up our water? It's right next to each other. And what do you think about that?
I haven't yet reached out to Tisbury to get their location information
Well, I know the information, and it is within zone 2, and it releases all that wastewater, or most of it. I'm not sure which proportion, but a massive amounts in that big green that is right next to the wastewater treatment facility and right next to the well. So I'm telling everybody about this. This is something that is not being discussed, and it is something that I think has to stop.
Well, I could say this tool would be available to look into things like that.
Good.
And hopefully would be useful for that.
Good.
I see Bill Lake's hand up.
Yes, hi. You mentioned time frame. I'm very interested. For those of us who are fascinated to see the results of what you're doing, you mentioned that the final report should be finished by the end of 2025. Do you anticipate that there will be any intermediate steps when you would be able to release your partial conclusions or partial information that you've gathered?
I would expect there could be an update via like a forum like this, Water Alliance, where we could show some results prior to the final. We do have to go through our fundamental science practices, which is a review process that can take quite a bit of time. So I do need to be careful about what we're sharing. But I would expect there would be some things that we could share.
Subject to those constraints, it would be wonderful.
Right.
Yeah. I have another question.
Go ahead, Anna.
Yeah. So we don't have the time, of course, and this is all an issue that does not seem to me to have a lot to do with our real problem, which is nitrogen pollution and algae infestations of our ponds. What we need to do right now is to start reducing it by 75% with IA systems And I'm not talking about the $50,000 ones. I'm talking about those that will cost $15,000 instead. And this is what we need to be doing, spending our time doing at the Water Alliance meetings as a great priority. And this needs to be starting immediately, 75% reduction within 5 years on all Title V septic systems, mind you, that are within the watershed areas of all of the ponds. So that's what I think we need to focus on. Thank you very much.
Thank you, Anna. David Foster.
Hey there, thanks very much. Terrific presentation and wonderful project. I especially appreciate all the openness and the availability of data and products and pointing us to other sources of information. I was curious if you could just say a little bit more about the soil water balance and recharge map and modeling that you did, and help to explain just a few of the variations in pattern out there. Thanks.
Yeah, so this is this part of the project is one of my coworkers' specialty, and she's explained it to me many times. And yeah, I mean, like I said, it takes those landscape characteristics and puts it into a spatial framework. So we can get this variable, the spatial distribution of recharge, but also seasonal. How has it changed seasonally? So like I said, we're using climate data, using the DayMet data, looking back in time to 2000. Going forward, we're using 2 different model scenarios, that business as usual, and then the other one, the moderate stabilization, in using the precip and temperature from those models to forecast what ET, essentially precipitation and ET, will be to get to recharge for the future. So what that produces is monthly recharge going forward through 2100. Where these climate change models tend to be bundles of 20 or more models in themselves, and so you can pick an ensemble or a grouping of different models and get all sorts of variability. But we have decided here to take a mean of 22 models, where we're still getting that upward trend. I'm thinking about temperature in particular right now, but we're not getting all this great variation that some of the models may predict. And so it was just, the uncertainties are pretty great. So we wanted to just kind of have that steady mean.
Great. Is there a source to dig further into the way that these models have worked and how these patterns develop?
Yeah, there's a USGS publication on SWME model by a guy named Weston Brook.
Okay, thanks very much.
Robert Nichols.
Sure. Can you hear me?
Yes.
Good,
Yep.
thank you. How soon are we to, I wouldn't say run out of water, but and maybe this should be directed to Sherry. Is there a question about rationing, or how we'd go about it, or under what conditions we'd go about it at this point? Is it a near problem or a far off problem?
Ooh, who wants to take that one?
Yeah, can I punt to Tim?
Yeah, well, my understanding, there's a lot of, this is a beautiful aquifer with plenty of water, and there's no shortage of water, of good quality water. So I don't believe that's an issue now. It's more, this project is really looking at how does that lens change over time. If you were to pump heavily at some of the production wells, does that change the interface position below that? It's hard to say. We really have to go through the study, but I don't think there's plenty of water here. The recharge rates are pretty high. Just like Cape Cod, there's lots of water. So quantity is not a problem for sure.
Okay, and quality. How about wells close to the shore, where are there any danger from the rise of sea level?
That'd be my question.
Yeah, potentially. I mean, that's one of the things. We'll produce a depth of water map and in the change in depth of water map, and it's likely that you'll see it closest to shore where you see that coming up. And so if you have domestic wells that are closest to the shore, there's potential there for a change.
I see Bill
that-
Lake's hand. Oh, you all set? Robert?
Yeah, thank you.
Thank
Appreciate
you.
it. Thank
Bill Lake.
Yes, I've heard it said that the island has a single aquifer, which I suspect is an oversimplification, but are there maps that show the extent of the aquifer and the depth of it across the island?
That's a good question. There's a main publication by USGS by David Delaney in 1980 that is a series of plates that show some pretty good information on where the aquifers are, but that may be a better question for the water suppliers and some of the consultant work that's been done prior.
Thanks.
Ben Robinson again.
Yeah, thanks. I had because we've been talking about this with the Army Corps, and they were using some old estimates based on sort of the recharge rates for the island. We raised a couple questions on those numbers due to if we were to look at future climate predictions for more intense rainfall and also extended drought periods. Should we look at the underlying methodology for recharge based on runoff that doesn't get absorbed? And also, how much does impervious surface play into the model that we're looking at on the screen? And do we need to recalibrate those estimates based on future climate predictions and also increased impervious surfaces?
Those are good questions. The first part of that, I'm not sure how to answer yet. The second part there, the SWB does account for impervious surfaces. You can actually see that on the runways of the airport in this slide here, if you can still see that. It does account for impervious surfaces. But yeah, it's interesting. We haven't really dug into looking at how things are changing over time on a month by month, looking forward, or season by season. We now have those data, and we can start to look at that using these SWB results.
Yeah, I'd be very interested if there is follow-up information there that we can sort of apply to the carrying capacity model, because they're using a static recharge rate.
Okay.
Yeah, thank you.
It may be a little bit of time before we can share that sort of information, but down the road for sure.
Yeah, great. Yeah, we'll continue the conversation. Thanks.
Thanks, Ben. Anybody else? I don't see anybody's hand up. Anybody else want to just speak up?
Hi, John
John.
Shirless here. Sorry, I
ahead.
couldn't get the hand up. Thanks for a great presentation and the excellent, very impressive work that you're doing. I have two questions. One is with respect to the western side of the island, whether the data that you've found shed any light on groundwater flow in those areas, which is understandably far less well understood than in the outwash plain. And the second question is to what extent you've availed yourself of any data, if they indeed exist, from commercial entities, people who are digging wells for a living, and the several companies that are dealing with water filter installation and monitoring on the island. Thanks.
Good questions. So for the Western Moraines, we've spent time looking at the distribution of those fine grained sediments, and as I mentioned, where the water, where water is detected in relation to those fine grained sediments. So sometimes you'll see it real high in the system where you have heads as high as 200 feet above sea level. Sometimes it's quite often over 100 feet above sea level. But what you see at some of those places is you also get those high heads even at sea level below those clays. And so there's always that question of, is it a confined system? If you're having heads that high, it has to be tied to land surface at some point in the system. So we've been trying to wrestle with this and how do we best simulate the system. And I think that, in either way, it's going to be a simplified version where we try to honor a few things like flow through the Millbrook, trying to honor these heads that we see that we know. And as well as we know that there's hundreds of domestic wells that are pulling from these fine grain or coarse grained areas that are pretty well determined. So there's these conditions that we're trying to match. We know we're not going to get all of these things perfectly. It's going to be a simplified form. Previous, studies have always just kind of cut off those moraines and not even looked up there. But we're going to just take an attempt, and it will be a simplified version of something. On your second question there, a lot of the information that we're gaining is from the well drillers. The well drillers databases that are reported to the state have been critical for all this information, including water levels and their logs. So that's really been important for this. As far as filtering, I haven't discussed with any folks. No.
I just thought of a question. Is there any way to measure how many gallons are pumped from individual on-site wells?
Yeah, when those are installed, they're tested, and that's also reported on those mass drillers database logs as well.
That's good. Good to know.
Yeah.
Anybody else? I don't see anybody's hand. Speak up. Well,
Richard, on that question you asked, one way to sort of extrapolate what those wells are pumping is just looking at the data with the municipal towns. So each person on town water has an individual account and an associated flow rate. And so you can look at a comparable property in a place where there's public water and say that type of property would have that kind of a flow, and then assign that to the private wells.
yeah, that's a good thought. Yep. Yeah, they monitor my water pretty closely. Anybody else? Sherry, got any questions? So I'm sure you've been in contact with Tim, and if he has questions, he asks you, right? And then figure out what the
Yes.
NBC.
Tim has been in
has.
contact with myself and Chris Seidel. We're in contact pretty regularly. So yeah,
Great.
we share the information. And this project will be a real big help to the island. So,
Yeah,
answer
it'll
all
be
questions.
interesting to see how much things change, how much quicker things change as climate change
Mhm.
happens.
Yeah, that graph with our water recharge was amazing. How much of a drought we were in. Good to see that we're coming back.
Yeah, it's so hard to figure that because it seems like we've gotten plenty of rain.
Mm.
But I guess it depends on when it comes down and how. And that's another good point is when we get these deluges of rain, most of it runs off into the ocean and doesn't get absorbed, correct?
Not sure.
Right,
So-
Tim? Is it one of the problems that when we get those big heavy rains that it doesn't have a chance to actually recharge, it just runs off?
Yeah, there's more runoff in those heavier events for sure.
And those seem to be the,
Nantucket's been even drier than Martha's Vineyard. And so we've had these huge storms here up near my office. I'm in Northborough. And it's been wet, and we've been in the 90th percentile for most of our wells up here. But on the islands, it really was quite low for quite a while.
Yeah, interesting.
Dan?
Dan, you got your hand up?
Yeah, I tuned in late, so tell me if this was already covered. So is the increase in projected total rainfall, is it a net gain when you ultimately, consider the loss and inefficiency of the percolation rate?
I'm not really sure of the question. I can,
So if we're getting our rainfall events, if we're getting our total rainfall in, in these more intense rainfall events, right, rather than a more equal kind of distribution, the percolation rate for those events is less efficient than if it was just kind of steady rain, across more total events in the year, right? That's
probably that
That's it.
sounds right.
So we lose efficiency in that respect as far as percolation goes, but we're expected to get more total rainfall. So I'm just trying to get a sense of what is
Yeah, the
projected.
balance of how to, it's
Right.
hard to say. And that's one of the things that we can look at with these data sets going forward. Like I said, we just haven't had a chance to dig into the results yet.
Okay, thanks.
Okay, and anybody else? I'm not seeing anybody, so thank you very much, Tim. That was great. Sounds like you've been busy.
Yeah, my pleasure. It's nice to finally talk to you guys.
It's nice that this work is being done.
Yes,
About
thank
drinking
you.
water.
Exciting project.
Big trouble. What was that question, Bill?
I just said thanks again. It's a really exciting project.
Is it exciting
Bill.
project?
Thanks, Tim. Thanks, Richard.
Okay, anybody else have anything that they want to report? Individual water groups have any information? I know we're just coming out of the cold season here, but I'm not seeing it.
Sherry, do you
Yes.
want to say what Lagoon Pond Association, your speaker talk will be for next month?
Absolutely. Thank you, Sherry. That's great. So the Lagoon Pond Association, Tisbury Waterways, Inc., Friends of Senji, and the MV Shellfish Group are holding we're starting a quarterly speaker series and about our Down Island coastal ponds. And the first one is going to be held on April 4th at the OB Library at 4:30, if I have that right. Don't quote me on the time. I think it's 4:30. And the title of this one's called Nitrogen Public Enemy #1. And we have 2 SMAS people coming in to give a talk, and would love to have people come and ask them hard questions. That would be great. Thank you.
Great.
That sounds great.
So,
Anna, you got a question?
yes, thank you. Well, okay, let me ask Sherry, please. I've been requesting a meeting with you, but let me ask it right here. Is the plan for the PRB still on for the sailing camp? I went down there the other day and there was no sign of anything happening. So I'm wondering what's happening.
It is still in the works. There has been no work done yet.
Okay, then I want to say that, do you remember, and everybody remembers, I hope, that I raised the question of the validity of that plan, because it would use, for the tiny little place that it did on at the bottom of Skiff Ave, it used 3,500 gallons of soybean oil, which required 50 acres of prime farmland to produce. And it will be, I looked at the land down there, and I could not imagine any place that would be more destructive to put a place like that. All the trees that are there that are currently sucking up nitrogen at a tremendous rate, of course. They would need to be removed and this filter put in. So I want to know what the plan is. I want to see the plan. I want to do everything I can to stop it, because it's an insane project. So is there any willingness among anybody to discuss this?
There will not be any trees removed.
There
We would,
won't be any trees removed. Where are you planning to put it then, I wonder?
just after, I'm sorry, Jessica got off the call. She had to get off the call because she's teaching a class. She's the person who puts the PRBs in that I work with. But it will be close to the shore. It will be between the tree line and the dunes.
And the dunes, there are
There's
no,
not a lot of room there.
No,
That's
no,
why
there's-
we're still
there's no
looking at that area.
there are no dunes. There's just the beach. And the
Right.
beach, the bushes go right up to the beach. So it's going to be completely submerged in salt water then, of course. And it's, I want to see this project. I'm sure you have it, the plan for it in the office. I'd like to make an appointment with you and look at it. And I want the Water Alliance, whose purpose it is to reduce the nitrogen in our ponds, I want the Water Alliance to get engaged in this issue and understand what the ramifications of it is and what the cost of it is to the environment, not just here, but in Maryland. And it's an absolutely, unacceptable project.
Okay. The
I want
PRB
to-
is still in planning, so
Yes.
it's not concrete
Okay.
yet. So there is no
Okay,
plan for it.
I say stop planning it. It is an insane project. Stop planning it.
Okay, Anna, we got it. Maybe you should schedule an appointment with Sherry and
Yeah, I've asked for that.
let's,
So please make an appointment for me, Sherry, okay? We have to
Sure,
talk about
will
this
do.
in great depth.
okay,
Okay.
that'd be great. Thank you, Anna.
Thank you.
Anybody else? Updates?
When it is a good time, I want to read a 5-minute thing. You don't need to grin.
Up, can't hear you, Sherry.
Sorry, I don't have my calendar open. That's why I smiled.
Okay. Okay.
I'll have to look at the calendar and I'll get
Very
back to
good.
you.
Sure,
She'll
that's
get- she'll get
great. You
back-
can
she'll
go
get
to
back to
see
you.
me, Sherry.
She'll get back to you. Okay, I think we're all set then, right?
Well,
Sherry,
I'm
anything else?
sorry.
I think we
I'm
are.
sorry. Yes, there is. I request 5 minutes to say something.
I don't know. What do you think, team? You wanna
What do you
listen?
say?
I'm just asking people what they think. They want to sit there for 5
You
minutes.
want to listen to 5 minutes? Am I talking about what's most relevant?
Okay, can you hold on 1 second? Can we just
Thank
thank Tim? And will this have any, will Tim have any input to this? Or I just want to let him go, or if anybody has any more questions for Tim? Richard, what do you think?
I've got a quick further question for Tim, if I may.
Go ahead, John.
Thanks. Sorry, Tim, thank you again for the work that you're doing and for sharing it with us. And thank you, Sherry, for arranging this. I may have missed it, but is there one site that you've got to which we could go to get whatever is now shareable and available from you about this?
Sorry, like a web page?
Yeah.
Yes, there is a general web page that I believe was linked on the announcement for this.
Okay, great.
But yeah, I think that'll get you started. Yeah.
Thanks again.
With the recording that I send out, I'll send that blip and announcement again so that it's all together.
Great.
Great. Okay, well, thanks, Tim. If you want to
Yeah.
leave, feel
Tim.
free. If anybody else
guys.
wants to leave, but Anna's got some information that she wants to share with us. So go ahead.
Thank you.
Thanks, guys.
Thanks, Tim.
Bye-bye.
Thank you. So I'm about to come out with a new website, and this part of it here is about how to restore our coastal ponds and estuaries. And I want to just read a brief introduction to it, and then I would appreciate it. I'm going to be sending it to you also, and I would appreciate any sort of feedback before I launch the website. In 1995, Massachusetts Department of Environmental Protection instituted new regulations for on-site septic systems called Title V. They were supposedly meant to reduce the pollution that was being caused by the older septic systems. However, this backfired badly because it turned out that these Title V septic systems would enable much more nitrogen pollution to seep into the groundwater, which drains into our coastal ponds. The DEP scientists knew that this would result in severe algae infestations, and they knew that this would cause great harm to these marine ecosystems. We know that DEP was fully aware of this threat from the beginning, because at the same time, they also instituted a new program for testing innovative alternative systems capable of reducing that nitrogen pollution. However, this testing program is in fact brutally discouraging, requiring 2 years or more at a remote military site on Cape Cod, costing at least $100,000 before getting permits to install on real-world existing on-site Title V systems. Consequently, the result is that after 27 years of this DEP testing program and many millions spent, there are still only a very few DEP-approved AI systems on the Vineyard. Over the years, several top officials of the Massachusetts Department of Environmental Protection have urged us to formulate a proposal for wastewater management plan for the Vineyard, with the primary goal of reducing the nitrogen that is released into our groundwater by Title V septic systems. Among these state officials have been Trudy Cox and Ellen Roy Hertzfelder, while each at different times held the post of Executive Secretary of Massachusetts Executive Office of Environmental Affairs, and therefore they headed the DEP, as well as Carl Honkonen, Robert O'Leary, and several. These officials all said the following, and I am paraphrasing: urge you for wastewater management, the Vineyard. Since such a plan is unlikely to come from DEP, it will have to come from you, the people of the Vineyard, whose ponds are being harmed by the nitrogen released by current Title V regulations. In accordance with these requests from the state, I've been developing a proposal for what would encourage the rapid, safe, and affordable development and testing of innovative technologies that may be capable of reducing nitrogen. Over the years, I have presented various preliminary versions of this proposal to the Vineyard Water Alliance, but sadly, it was never followed up by any discussion or action. This is the latest version of my proposal for doing exactly what the DEP is now finally requiring, which is reduce nitrogen pollution from all Title V septic systems located within any of the watershed areas of our ponds by at least 75% within 5 years by applying IA technologies capable of reducing nitrogen by an average of at least 75%. This is the time for us to step up and do what we know we must do in order to save our ponds and our economy. It's high time we stop kowtowing to the destructive regulations forced upon us by the state DEP. We must now stand up and say, no, DEP, we will not obey your demand anymore to use only those IA technologies that have been permitted by you, DEP. Up until now, this community has been unwilling to stand up for our inalienable right to protect our own water. Now we must stand up against DEP and with full commitment tell them, and tell ourselves, of course, we declare our right to protect our own water, and we will therefore no longer follow your regulations for how to manage our own wastewater. Instead, we will do what we know is best. So that is my introduction, and from that follows then the proposal that I will not take the time now to read, but I would, of course, appreciate if you all read it when I send it to you. And then I want to see a discussion about this, which will lead to the action that we have to take in order to save our ponds and protect our health and our economy. Thank you so much, everybody.
I know we've talked about this before, Anna, and we can talk about it again, but one of the things is Water Alliance is a different group of entities, so it's not its own. So it's because we all come from different sources. We come from towns, we come from private. So it's hard. Water Alliance has a difficulty getting behind that, and I know Gail can explain that better. And also, we do have to adhere to the Board of Health. We can't.
Yes, of course.
We can't put something in that the Board of Health is not going to approve.
Yeah, but you know something? The Board of Health is mandated, and they don't even acknowledge this. They are mandated to have, they have the final say. They are the ones who are responsible for obeying the the Clean Water Act. Our local boards of health have the ultimate responsibility. So we really, at the bottom line, is that we have to blame our boards of health for not doing their job of complying with the Clean Water Act of 1972, which is a federal act, federal law, which has also been adopted by state law. So that's the reality on that one. They have the right to do it. They have the obligation. They have the responsibility to do it. It is not up to DEP. They have usurped that role over I don't know how many decades, but you read in the instructions and it says right in the codes, right in the, again, my website, of course, will have all that information. It's right in there. It is not the DEP. It is our own boards of health who have the final responsibility to uphold the Clean Water Act. They have been in violation of this for, I don't know for how long.
Okay, talk to Richard if you would like to have some kind of a presentation. We can go from there. John?
Hi.
Oh.
Whoops. Thanks. Anna, thanks for sharing your thoughts and work. I'm just curious what it is that you're looking for from the Water Alliance, other than an opportunity to present information in a forum with colleagues, because of course it's not any kind of formally constituted entity. It's an informal entity. So, I mean, are you looking for approval or
Well, okay, I guess
a vote of approval from the Water Alliance, or just the opportunity to share these ideas and to get responses?
Well, of course, I'm looking for ideas and responses, yes. But I mean, I'm wondering, is there anybody who would disagree with anything that I say? I mean, does anybody still think that the DEP has this power over us to force us to pollute our own groundwater? I mean, is this really what people believe? And do they believe that that's okay to let them continue doing that? Is that what I'm hearing? Who would disagree with anything I said is what I'm wondering. And of course, I'm not talking about, I'm talking about individuals. We don't need to get together as an organization. I'm calling on individuals who care about healing our ponds. That's all. I don't hear you. I don't hear you.
So why don't you send out your information and, make your website available to everybody, and people can spend the next
exactly. That's
time
all
before the next meeting looking at this information. Then we can discuss it and make a decision about, what we might be able to do to move the process in the right direction.
Very good. Sounds good. Thank you. That's all I wanted to accomplish.
Okay, thank you very much. All right, anybody else? We all set?
I think we're good. Do we have any other announcements? I know April is Earth Day. I'm sure there's Earth Day cleanups. If anybody has any information they want to send to me that I can get out, Sherry, if you can send me the announcement for your speaker series, I can send that out to Water Alliance also.
Awesome, I will do that. And yeah, VCS is sponsoring that Earth Day event up at the museum again this year that they did last year. So it's kind of, I think starts at noon. It's after the after most of the cleanups are done, and you can go up there, and a lot of not-for-profits, environmental not-for-profits are going to be up there doing their thing. So yeah, thanks.
Okay. Thank you.
I'll share that evidently today is the International Day of Forests, the existence of which I didn't know of until today, but there we are.
Wow.
And
Thank you
David
all very
Foster
much.
has left us.
Yeah.
Yes, David Foster dropped out, so that's too bad. But yes, thank you. That's great.
And there's an MVC, something coming up at the Ag Hall, right? Our climate change
That will be in May.
in
So I can
May.
tell you about that next month.
Okay. Okay.
Dan,
All right.
do you know the date of that? Is that May 10th? I know it's a Sunday.
May 19th,
May
May
19th. Thank
noon
you.
to 4.
Noon to 4.
And that'll be really great, but I will send that out to Water Alliance and we'll talk about it next month.
It's
Okay.
gonna biochar demonstration.
That will be part of it. But it's the whole climate adaptation. You know, Liz wants to really get out there, you know, what can you do as just an individual person, you know, because it is overwhelming when you look at it all together. So we're going to try to get the word out. So, okay, I think we're finished.
All right. Thank you very much, everybody.
Thank you,
Thank-
guys.
Enjoy
Thank
the
you.
next,
Nice to see
Thank you all
everybody.
very much.
spring day.
Bye.
Bye-bye.